Okay, so the probability of all females, 3/9 times what? And is that 1 over 84? Okay. What about now for one male and two females? Well, let's kind of think about that one. That could be male, female, 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 male, female, and female, female, male. So 6/9 times 3/8 times 2/7 plus 3/9 times 6/8 plus 2/7 plus 3/9 times 2/8 times 6/7, and I think you get 3 times 36 over 504, or 3/14, I believe. Where am I? Come on, get over. There you go.
You said 3/13?
14th. Is that what? Anybody get that far ahead and get that same number? All right, and then that's the probability of at least one female. What's the thing to do? Try to find the complement. Right, so the complement would be 1 minus the probability of at least one female, which equal to 1 minus 6/8 times 5/7 times 4/6, which is equal to 1 minus 5 over 21, or 16 over 21.
You're taking 1 minus the probability of at least one female, or the 1 minus the probability of all the males?
Oh, yes, all males. Sorry about that.
Denominator is supposed to be 987.
Which one up here?
No, down here.
Oh. Yeah, what come I got the 8? Ugh. Step ahead of myself. I'm sorry. 987. Still getting used to wearing glasses.
That would change our final probability, right?
I don't think so, because I think 120 over 72 times 7, 504 simplifies to 5 over 121.
Yeah.
Okay.
So we got 16 over 21.
Yeah. Yes, Mitch?
So the probability of at least one female, we're doing 1 minus with all males.
Yeah.
Should we go, because there's 6 males, should we go down all the way to 1 instead of 6?
No, because we're only taking 3 people for our juror.
Okay.
All right, so this is kind of a special case of the product rule, and this is the permutation. The setting is that order matters. And in this case, you're looking at the number of possible arrangements. And the counting formula is NPR. And so you have to think about this. You know, we have 10 people. We're going to have, we're going to pick 3 of them. We'd have 10 times 9 times 8. So in other words, we could say 10 factorial divided by 7 factorial would give us the number of possible places for first, second, and third. So in this case, you would have n factorial over n minus r factorial, which is another way of saying n times n minus 1 out to n minus r plus 1. So 10 factorial over 7 factorial, 10 times 9 times 8. So So let's suppose we want to get a elect a president for the Dr. T fan club. In this case, you have the president, the vice president, and the secretary. You have 6 members, so this would be 6p3. In other words, 6 factorial over 3 factorial, or 6 times 5 times 4 over 120.
How does order matter in that situation?
Well, because suppose I select 3 people out, one of them has to be the president. If I select you the president, Katie vice president, or Katie president, you vice president, that's another arrangement that could be counted.
Okay. So it's not equal to 3, it's a picking the president order and then the vice president?
Yeah.
Okay. Perfect.
Yeah. Let's turn to page 25. Oh, that's just another repeat of order mattering. And I've already written down what that is. So now the special case is that if n is equal to k or n is equal to r, then this is equal to n factorial, or in other words, n factorial over n minus n factorial, or n factorial over 0 factorial. And that's another reason why we want 0 factorial to be 1 factorial, so we can get n factorial. So this is my NPN, and that's where I get the n factorial part coming from. Yes?
What would be an example of that?
Oh, I want to pick the 5 top people who have the highest metabolism rate in the next class. Turns out only 5 people show up, and if I'm going to rank them, it's going to be 5P5 and 5, 4, 3, 2, 1. So 120. Okay, let's pause for a couple seconds and think about what we've had so far, because we're going to add another wrinkle here.